Every video game relies on a user interface to present information and allow interaction. In this game, the primary interface is a graphical user interface, or GUI, where players interact through floating windows to view and modify the game state. In the game, there are several screens and windows. The very first screen is the intro screen that displays a couple of options: New World, Load the World, Options, and Exit. The screen uses the control node to bundle all elements. The first node inside of it is the texture rect node that acts as the background for the whole screen. Its expand mode is set to ignore size, so that it conforms to the predetermined resolution of 1280 by 720 pixels. Next is the label with the name of the game. Its position is set to be in the upper third of the screen. Next, we have a panel container in the middle of the screen. This container provides a dark frame around another panel container which has a lighter background. Inside that inner container is a VBox container node that allows you to position elements vertically. There are 4 buttons in this menu: New World, Load a World, Options, and Exit. The New World button instantly enters the game and generates a random world. The Load a World button opens another screen with loaded save files. The Options button triggers a floating window that has a few options, and the Exit button closes the game. Each button is listening to the pressed signal, which is programmed in the script that manages the intro screen. For example, this is what the methods for Exit, Settings, and Load Game methods look like. As for the color palette, I am using Solarized Dark. You might have noticed that both panel containers have rounded corners. This is done using the 9-patch approach. 9 patches can be created in an image editor like a sprite. In this case, I have created a 15 by 15 patch with rounded corners. I am specifically using an odd number because in my experience, Godot can scale these textures more efficiently. Then inside the panel container settings, you can come down to Theme Overrides, Styles, Panel, and create a new style box texture. Inside, you can import your patch texture and update the texture margins to capture your corners. In my case, the middle of the texture is a solid square and everything around it makes up the border and corners. To set that up properly, I split the 9-patch 5 pixels in from each side, so top, bottom, left, and right, so all the texture margins are set to 5 pixels. Now, whatever I put inside of it will get a nice rounded pixel art frame. The Load a World menu opens another screen where you can manage your save files. Each world is named after its seed and can either be loaded or deleted. This is done through pressing either one of these 2 buttons, arrow up to load it or a trash icon to delete it. This screen is very similar to the intro one in that it bundles all elements, displays the background, and uses the title label. One thing that is new here is the scroll container. Since you can have a lot of save files, this lets you scroll through them. All available save files are loaded into this VBox container. There is a signal on that container that listens for insertions and deletions of entries. This is a simple method that checks how many children live in that container, and if that number goes to 0, a new label is shown, instructing the player that no save files exist currently and that the player is prompted to create a new one. At the bottom, there is a main menu button that reverts to the initial intro screen. The Options menu exists both inside the game and in the intro menu. Currently, it's very simple and contains options like integer scaling to ensure that pixels are multiplied by whole numbers to prevent fractional scaling and potential tearing, which is useful when changing resolutions. Full screen removes the borders from the window and makes the game, well, full screen. The volume slider calls the setBuzzVolume method to manage the in-game volume. This component uses the 9-patch approach, same as we've seen with the panel container before, to achieve rounded pixel art corners. The in-game UI has the most graphical components. The whole GUI exists on a canvas layer so that it always stays on top and doesn't react to camera transforms. The whole UI is bundled in a control node. The very first node is the label node that specifies which floor we're on. This is helpful when exploring dungeons. Next is a margin container which holds several components. The nice thing about margin container is that it allows you to set margins easily. All elements inside of it will get pushed inwards from the edges of the screen. By the way, a new feature has been implemented in Godot 4.6 where you can visualize the margin container's outline by selecting it. In the bottom right corner we can see 4 buttons. One of them triggers the escape menu similar to the one we've seen in the intro screen. The only difference being that it allows you to exit to the main menu. Next up we have the recipes button. This one opens a window and lists all the recipes that are available in the game so far. Each entry describes an item that is to be crafted, its ingredient list, and the craft button. Pressing the craft button disables it for a few seconds, giving you a visual representation of an item being crafted over time. After a few seconds, the crafting is considered done, giving you the crafted item and re-enabling the button. Next is the Statistics tab. This one displays the state of your networks. Here you can see how many electrical networks you have in your world, how much energy is being produced on average, how much energy you are storing, how much energy you are using, and how many pipe items are currently circulating through transport pipes. The last button is your inventory. Here you can see all the items that your character possesses. In the top right corner we can see the wire toggle. This button makes all machines semi-transparent to allow you to see your cable layout more easily in the world. At the bottom of the screen we can see the hotbar. This is part of player's inventory which allows you to hold items in your hand. An item that is in the hotbar and currently highlighted can either be placed down or used. To use an item, use the left mouse button click, and to place it down, use the right mouse button click. To transfer a sword to the hotbar, you can simply click on it in your player's inventory. Now this item floats next to your cursor. You can finish the transfer by pressing another inventory slot, for example the one in your hotbar. The hotbar also reacts to numbers 0 through 9 to transfer them to the hotbar quickly. To do that, simply hover over an item in an inventory and press a number between 0 and 9. In the bottom left corner we have the Harvest Manager. This component shows what we are currently looking at and in what amount. It also displays a progress bar that indicates how long until the harvesting is done. Once the progress bar reaches 100%, it subtracts 1 from the resources amount and spawns an item on the ground. There is a category of windows that are movable. These are windows that can be moved freely on the screen and are usually spawned dynamically, which means that you can have multiple instances of them. Windows are moved thanks to a special script that listens for mouse clicks and mouse movements and snaps that window to the mouse's position if it is currently in the dragging mode. In that same component, there is a close button that hides or destroys the entire window. It also has a title to indicate which object it corresponds to. Each machine has its own special window that displays information about that machine. For example, this is the interface for the chests, a simple grid of inventory slots. This is a solar panel's interface that shows you how much energy it has produced. And this is a furnaces window that shows you the stored energy, raw items, fuel, the progress of smelting, and the resulting inventory grid which stores the smelted products. This is the interface for an item pipe. Its interface is slightly different. Each side is configurable separately, so each pipe can pull items from multiple inventories using separate servos on each side. In the future, I'd like to implement item sorters to allow for a fine-grained flow of items in the system. Item tooltip is another component. This one shows you the statistics of items. For example, a sword might display its attack strength or its pushback strength. A bow might display its ranged damage, a machine could show you its battery level, or a food item can show you how much health it's going to restore. This component is shown on item hover. There are also 3 other tooltips to indicate the progress of the machine, its battery level, or its accumulated heat, each displayed upon hovering a progress bar in a machine's interface. The Harvest Manager can also show that information. Some tools have durability, which is displayed at the bottom of the inventory slot. The colors go from green to orange to red, depending on the health of the tool. There's also a health indicator, an attack cooldown indicator, and a food consumption cooldown indicator that have been explained in another video already. So this is the current state of the UI. Overall, I am happy with what Godot provides out of the box. So far, I was able to build anything that I wanted with the tools that are available by default. In the next video, we might explore save files, meaning how worlds are saved and loaded. Thanks for watching.